Okay, let's unpack this. For decades, lighting was just a passive utility. You flipped a switch and a bulb glowed. That was it.
Completely passive. Simple.
But the sources we've gathered for this deep dive, they show something completely different. That the humble light fixture has actually become one of the most exciting pieces of modern infrastructure.
That's absolutely right.
It's no longer just about illumination, it's about connectivity, data capture, and really long-term sustainability.
It is. We are analyzing a global revolution, and it's being led by smart LED solutions. Our mission today is to, cut through some of the marketing noise.
Right.
And synthesize exactly how this technology is transforming our spaces from these huge industrial complexes right down to your kitchen. And crucially, we have to talk about the unsung hero that makes it all possible.
The material science.
The material innovation, yeah. Specifically, the role of high-performance aluminum extrusions.
So, if you're looking for a genuine shortcut to understanding this, explosive global shift and why countries like India are setting the pace for massive growth, this deep dive is for you. We're going to give you the technical and the economic reasons why modern lighting is smarter, greener, and in the long run, just drastically more affordable.
To start, I think we have to appreciate the sheer speed of the change. We spent over a century optimizing the incandescent bulb.
That old warm glow.
That comforting but hugely inefficient warm glow. Then came the necessary energy efficient, if sometimes a bit harsh, CFLs. But the LED, that wasn't just another step. It was a conceptual leap.
The sources really emphasize that LEDs became the global choice because they just fundamentally altered that cost-performance equation. They set new benchmarks that the older tech just couldn't meet.
Exactly.
It wasn't just about being efficient on day one. It was about being efficient for a decade or more.
Precisely. We're talking about a lifespan that can reach, 50,000 operating hours?
50,000.
Compare that to maybe 1,000 for an old incandescent. And this durability, it translates directly into operational savings. And critically, unlike older tech that wasted so much energy as heat.
Right, you could feel the heat coming off of them.
Yeah, LEDs are highly energy focused. They generate minimal ambient heat. And that's a game changer, not just for safety, but for reducing the load on HVAC systems in big commercial buildings.
And when you combine that low heat with their compact size, the design flexibility is, it's limitless. You can mold them into architecture, stick them in tiny electronics.
Or build massive, resilient floodlights. It's all possible. This shift really signals a commitment across the whole ecosystem, manufacturers, governments, consumers, to making smarter, longer-lasting, and truly sustainable choices.
Okay, here's where it gets really interesting, though. Because if LEDs were just efficient bulbs, we probably wouldn't be doing this deep dive.
No, we wouldn't.
The revolution happens when lighting transitions from just a fixture into an intelligent node on a network.
That's the word smart. It means connectivity and it means data. It starts with the efficiency baseline. Yes, up to 80% less power, which is the immediate financial hook.
Of course.
But the true value is that integration. We're talking seamless connectivity through Wi-Fi, Bluetooth, or specialized networks that link up to smart home systems, voice assistants.
Or even entire city management systems.
Or sophisticated central city management systems, exactly.
It's just fascinating to me that we're now using lighting to manage something so far beyond illumination. Sure, there's convenience dimming for ambiance, app control, but there's also really sophisticated energy optimization.
Well, the primary gain in the commercial and industrial space is predictive maintenance. Think of 1,000 streetlights in the city.
Okay.
In the old system, you waited for someone to call and report an outage. Then you dispatch a costly crew with a lift truck.
A completely reactive process.
Totally reactive. With a smart LED system, each fixture is constantly reporting its status, its operational hours, its dimming level, and this is the crucial part, its internal temperature.
So the system isn't just waiting for it to fail, it's using the data to, predict it?
To predict failure, exactly.
Yeah.
So if a fixture, say in the north sector, started reporting just slightly elevated operating temperatures.
For a few weeks or something?
Yeah, over maybe 3 consecutive weeks, the central system flags it. That suggests a driver component might be degrading, or maybe the thermal housing is blocked. The city can then dispatch a crew proactively during scheduled rounds.
Which drastically reduces emergency callouts and maximizes uptime.
That's the difference between simple illumination and intelligent infrastructure management.
So that integration of data and control is the core of the smart argument. But we have to address the green and affordable arguments, too. They feel very intertwined.
They absolutely are. And sustainability, it starts with material composition. Conventional lighting often had hazardous stuff in it, like mercury.
A huge disposal problem.
A significant disposal issue, yeah. By contrast, LEDs are generally made using eco-friendly and fully recyclable materials, so they're inherently safer for the environment and for the people who handle them.
And when you look at the carbon footprint, the long-term impact is just undeniable. All that lower energy use, plus those huge life cycles.
50,000 hours means less manufacturing waste, fewer trucks carrying replacements. It's an easy, really impactful step toward carbon neutrality for organizations trying to hit those ambitious climate goals.
Which brings us to affordability. It's a common misconception, right, that smart, durable tech has to be expensive.
It is, but the source material shows that the cost curve for LEDs has just plummeted over the last decade. It's transformed them from a high-end luxury item to the market standard.
How did that happen so fast? It has to be economies of scale and just getting better at making the components.
Precisely. High-volume manufacturing means component costs drop all the time. But the real affordability is realized through what's called the total cost of ownership, or TCO. So while the initial price might be a bit higher than an old bulb, that 80% power reduction on your utility bills, combined with basically zero replacement costs for years, it means the payback period is often surprisingly short.
And we can't ignore the role of policy here. That's often what drives those economies of scale in the first place.
It's a huge factor.
Governments worldwide are giving that necessary nudge, right? With initiatives, subsidies, tax rebates, all to accelerate mass adoption.
Absolutely. Look at the Indian market, for instance, which is just seeing rapid expansion. The sources highlight how government support for the renewable sector, often through these massive centralized bulk procurement schemes, makes LED tech instantly accessible and financially viable for millions.
When you buy 10 million bulbs instead of 10,000.
The cost plummets. And that policy-driven volume ensures that the entire domestic manufacturing ecosystem benefits and gets stronger.
It's a classic positive feedback loop. Policy drives volume, volume drives down costs, and lower cost accelerates adoption. But, and this is the thing, all these savings, the efficiency, the durability, the reliability, they all seem to rely entirely on one physical bottleneck.
They do.
The material science. We've talked chips and software and government policy, but we need to talk about the housing itself.
And this is the perfect transition into the unsung hero we mentioned, the role of aluminum innovation. Without advanced thermal management, that promise of a 50,000-hour lifespan is, well, it's void.
It's meaningless.
The delicate LED chip, the emitter, it fails when its internal temperature, what's known as the junction temperature, goes over its threshold. And that can happen within months under sustained use.
So if the heat gets trapped, the efficiency dies and the bulb dies quickly. The goal, then, is to get that heat away from the chip and dissipate it into the air as fast as you possibly can.
That's the function of the heat sink. And that's precisely why aluminum extrusion manufacturers are so essential. They create the robust, precision-engineered profiles, the frames and housings, that act as the cooling system for the whole fixture.
Why aluminum specifically? What makes it the perfect material for this kind of highly technical job?
It offers a perfect blend of three properties that are critical for lighting infrastructure. First, it's lightweight, which makes installation easier and reduces structural load.
Sure, that makes sense.
Second, it's incredibly durable and corrosion resistant, which is perfect for outdoor infrastructure. But most importantly, it has superior thermal conductivity.
And this is where the engineering comes in, because we're not just talking about a flat piece of metal.
Oh, no, not at all. We're talking about precision extrusions. The process involves heating specific aluminum alloys, often the 6000 series, which has this optimal mix of strength and conductivity, and forcing it through a shaped die.
Okay.
This lets manufacturers create these incredibly complex, often finned or grooved profiles that just maximize the surface area exposed to the air.
More surface area, faster cooling.
The more surface area, the faster the heat transfers, and the lower that junction temperature stays. This is how that promised longevity is physically realized. It's pure physics.
It's fascinating how this one material connects the two critical parts of the energy revolution. We see aluminum not just in managing the heat on the consumption side, the LED fixture, but also fundamentally on the generation side.
Absolutely. We see the exact same material science applied in power and energy sections for reliable energy transfer and structural support. The sources specifically mentioned its crucial use in aluminum solar profiles.
So the material that's keeping your smart light cool is the same durable, lightweight structure holding up the solar panels that power it.
It's the material that bridges the entire renewable energy ecosystem.
So if we connect this to the bigger picture, this blend of smart tech and durable, thermally efficient aluminum is creating truly sustainable and resilient infrastructure across, well, every imaginable sector.
Let's start with the place you know best, residential, smart living. Here, LEDs offer customization, different color temperatures, zones, remote control, but the material science ensures those sleek interior and exterior fixtures are heat-resistant, reliable, and durable.
Right, even when they're on for hours in a confined space.
Exactly. Then you move into the commercial sector, malls, offices, hospitals. Here, the focus shifts to massive energy reduction and human performance.
Right, cutting huge electricity costs,
Well,
but also using that customized brightness and color to improve productivity or customer experiences.
and that durability factor is critical here, too. Imagine a large warehouse. Downtime is incredibly expensive. Switching to LEDs housed in these robust extruded aluminum profiles means the fixtures can withstand constant operation, dust, minor impacts, without failing.
Which reduces huge maintenance risks for facility managers.
Then you hit the truly demanding environment, the industrial sector. Here it's all about robustness, vibration resistance, safety. Industrial LED solutions are designed for harsh conditions: heat, dust, moisture, even chemical exposure.
So the aluminum extrusion profile isn't just for cooling there, it's a protective barrier.
It becomes an essential protective barrier, yeah. It seals and protects sensitive components, drastically reducing downtime. When you're dealing with high bay lighting in a factory or a refinery, reliability is paramount, and that physical housing is your primary defense against failure.
And finally, you get to the true public scale, the smart city model. We talked about predictive maintenance, but think about the physical integrity of a streetlight on a highway or a bridge.
Right. Illuminating roads and bridges requires maximum reliability and minimum consumption. The combination of smart controls for dimming and motion sensing, paired with extremely durable, weather-resistant aluminum housing, it all contributes directly to smarter, greener infrastructure.
Infrastructure that can basically manage itself for decades, standing up to harsh weather and heavy use.
The longevity of the material finally matches the longevity promise of the chip inside it.
So what does this all mean? The sources make it absolutely clear that the global lighting sector has undergone this fundamental transformation. LEDs are not passive bulbs anymore. They're sophisticated, interconnected, sustainable systems.
And they are dramatically reducing energy demands and creating intelligent, data-rich environments all over the world.
And I think the essential lesson here is that the technological promise, the smart control, the efficiency, the extreme longevity, it's all completely reliant on advanced material science.
It is. That critical thermal management and the inherent durability you get from precision aluminum extrusions, that is the physical engine driving this entire revolution.
We've moved from a simple, fragile filament to complex, interconnected, eco-friendly city infrastructure. And now that this massive adoption of smart LED tech is the new global baseline, the innovation, it's not going to slow down.
No, it's only going to accelerate.
Which raises a really important question. How will the next generation of aluminum solar profiles and fully IoT integrated public lighting systems transform the physical design, the functionality, and even the energy independence of our modern cities in the next 10 years?
That is the future that is already being built.
Ah.
Thank you for diving deep with us.